So guys, this is the electrical engineering student syllabus where you have the continuous time and the discrete time signals, shifting properties, scaling properties, LTI system, causal system, Fourier series, sampling, Fourier transform, Z transform, Laplace transform, and average value calculation for any periodic signal. These are the topics that you have in your syllabus for the electronics students. For electrical students, for electronics students, this is the Fourier series, Fourier transform, basics of signals and systems, DTFT, DFT, Z transform, and LTI system. There is no topic mentioned like a Laplace transform. So Laplace transform is not there directly in the signals and system, but it is there in the mathematics. So they asked us some question from the mathematics part. So, what I taught you in the actual course, those who were studied in the previous batch, I have taken those reference notes so that we can very quickly go through all the concepts and the solution of the questions. Because if I give you the question and then I will wait for your answer, then it will take time. So we will quickly wrap up the whole syllabus because we have whole notes. So I will be telling you each and everything. Like here, the signal is a physical quantity, like you, where by which we transfer the amount of information. So like in this stock information, you have a different time, and in the different time you can observe the stock market, and that will give you the market scenario that whether this stock is market is going up or down at particular time. And the political party performance for this number of seats in the different years are different for that particular political party. And signal is a function of one or two independent random variable, like we write x of t. So in that x of t, the x is a time dependent. That means the time t is the independent and x depends upon the time t. So x depends upon the time t, like xt is equal to sine t. So when you change the time, xt will get changed. Two dimension, when x and y both are simultaneously changed, then we call it as a two dimension. And then three dimension, okay, the block and the TV picture, like we have a three space, and similarly four dimension also, that with the temperature and the function of temperature in the room. This the point in the room is a three dimension, like we have a x y z, but the at a different point at the different time we can have the different temperature of the same point. Of the same point we can have the different temperature. So this is the main topic, signals. Amplitude scaling, amplitude folding, time shifting, time delay, time advance, time scaling. We have two types: signal expansion, signal compression, and time folding. Amplitude scaling, suppose there is a signal xt. Just a second. Actually. So this is the amplitude of the signal 1, and when you amplitude scale it by A, it will be represented by AXT. The working rule is simple, that the signal is simply multiplied by the amplitude factor A. So in amplitude scaling operation, the width does not change, and unchanged, only the amplitude is changed. Only the amplitude is changed. So in the amplitude folding, just you multiply the amplitude by 1. If you multiply the amplitude by 1, then -1, then it will be inverted. The positive side of the amplitude will become negative and negative side become positive. So that is the amplitude scaling. Okay, this is the amplitude scaling minus sign. So amplitude folding operation can be viewed as amplitude scaling factor by -1. So if you will see this example, now for the signal x of t, this is the signal x of t which is given. This is the signal x of t which is given, which has the amplitude 2. Okay, this amplitude is 2 and the area of this signal is 8. That is rectangular signal. So 4 into 2 is 8. Now we want to amplitude scale by 5. So if you want to amplitude scale by 5, then the signal will become 5. So 5, the height of the signal will become 2 times of 5. That is, previously it was 2, now it is 2 times of 5, that become 10. So area also you can see this is 40. So with respect to the previous area was 8, now it is 40. That means 8 into 5. So what is 5? 5 is nothing but the factor by which you are multiplying the amplitude. Similarly, here also -2. So what is the -2? That is the amplitude by which you are multiplying. So the 2 multiplied with -2 become -4. So area height will become -4. That is negative scaling. It is amplitude scaling inverted also. So it is amplitude scaling, but also inverted. Amplitude inverting plus amplitude scaling. So here it is -4. So when we multiply, it will be -4. So when we calculate the area, it will be -16. But we take the area as a positive quantity, hence the area will become 16. So what is 16? That is nothing but the previous area was 8, and now we are multiplying with the factor 2. So that means the amplitude is scaled by the same factor by which we area is also scaled by the same factor by which we scale the amplitude. Okay, the amplitude we scale is k, then the area become k into a. If suppose you find any difficulty understanding any concept, just let me know so that I will be repeating the particular topic. And like this type of signal, suppose you see, so this is positive, this is negative, this is positive. So when you calculate the area, the all the area which is above the time axis are taken as positive, and the area which is below the time axis is taken as negative. So if I ask you to calculate the area of the signal, then this is A1 minus A2 plus A3. A1 then minus A2 because it is below the time axis and plus A3. Now we have a time delay and time shifting operation. So time delay means shifting towards right. Okay, time delay means shifting towards right. So suppose you want to start anything at 5 a.m. but you are starting at 6 a.m. That means you are delaying the thing. Whatever you want to do, you are delaying that by 1 hour. So you can see that in the time axis, this 5 p.m. and then this 5 a.m. and then the 6 a.m. This a.m. is nothing but a delayed version, that is shifting towards right. Hence the time delay is called shifting right. Time advance is called shifting left. That means we shift towards left. Because advance means you are starting early. When you start early, that means you have scheduled anything for 5, but you started it early at 4. So that means you are shifting towards left. Now, what is the rule? So when you want to shift the signal towards right, it is represented by minus sign. So t minus a. So when you will equate it to 0, that you will get positive quantity. So you are getting positive quantity means you will be shifting towards right. Positive from the origin, the positive side is right, towards right. So that is how you can understand that why the time delay is shifting right, because you get the positive value, and that is why the representation is t minus a. That is why the representation is t minus a. Okay, so like xt minus 2. If you want to represent the same signal xt by minus 2, if you want to delay it, so xt is given as 2 between minus 2 to 2. If the time axis is minus 2 to 2, so this is how you represent minus 2 to 2. Okay, now if you want to write t minus 2, so you will write t minus 2, so replace the t by t minus 2. So here also you replace the t by t minus 2. But we have the time axis, so we have to represent in the time axis. So when you want to write t, there's minus 2 you have to ignore. So minus 2 you can ignore by adding 2. So when you will add plus 2, so minus 2 plus 2 becomes 0. You will add plus 2, it will become t. You will add plus 2, it will become 4. So t will become 0 to 4. So 0 to 4, the height is 2. 0 to 4, the height is 2. Elsewhere, it is 0. T minus 5. Okay, so t minus 5. So now minus 2, t minus 5 less than 2. So plus 5, if you add plus 5, you will get 3 to 7. You will get 3 to 7. So in this way, we have 3 to 7, the height is 2. This is the delayed version. Now you have to advance. Advance means left shift. The same procedure you have to follow. Just the representation is t plus a. So when you will take the t plus a equal to 0, the t will become minus a. Time is negative. That means you will shift towards left. So here t plus 2. The same signal. X of t is 2 from minus 2 to 2. This is the same signal which we have studied. You can't see anything. You can refresh it because I think others are able to see the things, right? So t plus 2. So replace the t by t plus 2. So this is t plus 2 and minus 2 to 2. And we have to write t. So just subtract by minus 2. So this will become minus 4. This will become t. And 2 minus 2 becomes 0. And otherwise. So area will be 4 into 2, that is 8. So area is not changing. in the time delay and the time shifting property, time delay, time advance property, the area will not change. Only the position of the signal will change, whether it will be left or it would be right. Is there any doubt up to this operation? We have got the two operations, the time scaling, so time shifting and amplitude scaling and amplitude scaling. Now the signal expansion and compression, which is the signal expansion and compression is nothing but the time scaling property. Now, the same procedure you have to follow to write any signal. Okay, like x of t is represented by x of at. Now, if a is greater than 1, then the signal gets compressed. A is greater than 1, signal gets compressed. A is less than 1, signal will get expanded. Again, we will take the same signal. X of t is minus 2 to 2, it is 2. Area is also 8. Now we have to replace the t by 2t because now you want to draw x of 2t. So t is replaced by 2t. Now our axis is t, but here
You are currently the only person in this conference.
you will divide it by 2, it will become minus 1, it will become t, it will become 1. So minus 1 to 1. So minus 1 to 1. So in compare with the previous signal, the signal is get compressed because the factor a, here a is 2. So the a is 2, which is greater than 1. So if the a is greater than 1, the signal get compressed. Now the a is 1 by 2. A is 1 by 2. So what you are doing, you are multiplying it by 2. Okay, you are multiplying it by 2 to get the complete value, the t value. So minus 2. So you are multiplying with 2, 2, 2. So 2 into 2 minus 4. This is t and this is 4. So now the signal will get expanded. So signal is expanding. So here you can see the area also. So signal will get expanded by the same factor a. So, so area will get changed by the factor a. Previous area was 8. Now the area is a is 2. So the area become 4. So that means, and you can say that area is divided by the factor a. Area is divided by the factor a. That is the scaling factor. Area gets divided by the scaling factor. Area gets divided by the scaling factor. Okay. So that is the general form. X of t has the area A. X of at will have the area. Area will always get divided by the scaling factor. Area will get multiplied by the amplitude scale. If there is an amplitude change, then the area will get increased. Okay, like if we have, uh, if suppose x of t has the area A, then 2xt will have area 2a. But 2xt by 4 will have area 2 into a divided by 1 by 4 because a is 1 by 4. So it will be 8a. So this signal x of t is having the area a, then 2xt by 4 will have area 8a. Time folding, just the scaling factor will become minus 1. So a become minus 1. If a is minus 1, if a is minus 1, then when a become minus 1, the procedure is same to draw, just that a is minus 1. So this is the, suppose the diagram x of t. Now we have x of t by 3. A is 1 by 3. So A is less than 1, so signal will get expand. So A is 1 by 3, the all the factor will multiply with the 3. Okay, this minus 1, A is 1 by 3. So minus 1 is divided by 1 by 3. So this minus 1 divided by 1 by 3 become minus 3. So this is minus 3. All the term here also 1 by 3. We will get 9. So this is 9. So signal will get expanded like this. This is 1 by 3. So you will get 3. So this is 3. Similarly, A is 2 here. So if A is 2, the same procedure you have to follow, divided by 2. Divided by 2. So if I divide it by 2, divided by 2, divided by 2, 0 0.5, 0 0.5, 1.5. X of minus t, A is minus 1. So when A is minus 1, just divide it by minus 1. Whatever will be the value of A, to draw the diagram, just divide the time axis by A. So divide it by A. So the signal which was at 1, minus 1 will become 1. So the signal, this signal was at 1, this signal was at minus 1, now it will be at 1. This will be at minus 1, this peak value will be at minus 1, this peak value is at minus 1. When you divide it by minus 1, it will become minus 3, so this will become minus 3. Like this. So now if the signal x of t has area A, then in the generalized way, kx at plus minus t naught will have area. What will be the area of this? This T naught will not have any effect. This T naught will not have any effect because this is shifting. Area will get multiplied by the same factor K, and by the scaling factor it will get divided. So K into A and scaling factor it will get divided. Like x of t has the area as a 5 unit. If it has the area as a 5 unit, then minus 2 x3t plus 5 will have area. A is 2, so area will be 2, and the small a is 3, so it will get divided by 3. So what will be the area? Minus 10 by 3. It depends upon the option that whether you want to take the sign or not. Any doubt in this? So we have completed how to draw the signal, that means signal operation we have completed. This is the basic signal operation, that how do you represent the signal and how do you perform any operation in the signal, like how do you do the shifting towards right, left, scaling, that means compression, expansion, and time folding. Okay. Now discrete signal representation. We can represent the discrete signal x of n 1, 2, 3, 4 like this. So this is the point where n is 0. If nothing is given, that means the initial point is n equal to 0. If nothing is given, then the initial point is n equal to 0. Okay, so at n equal to 0 it is 1, and at n equal to 0 we represent in this way. That is simple. Vertical line. By this way we represent the discrete signals. Like here x of n is equal to -1, 2, 3, -2, and if the arrow is shown here, so that is nothing but the value of n equal to 0. So this is the value of n. So n equal to 0 we have 2, n equal to -1 we have -1, n equal to 1 we have 3, n equal to 2 we have -2. So these are the operations that you can do x of n. This is 2, -1, 3, 4 and 1. Okay, so n equal to 0 we have -1, n equal to 0 we have -1 here. Okay, n equal to 0 we have -1, n equal to -1 we have 2, n equal to 1 we have 3, n equal to 2 we have 4, n equal to 3 we have 1. So this is representation. Now you can write x n plus 2. N plus 2 is the advanced operation. N plus 2 is the advanced operation. So n is equal to -2. That means you have to shift it by 2. Which side? Because it is advanced, so we will have to shift towards left. So -1 will be shifted 2 towards left, so -3. That will start from -3. 0 will shift towards left by -2, so it will be -2. So at -2 it is -1. It will be -1, it will be 0, it will be +1. So we have got this 2, -1, 3, 4, 1. 2, -1, 3, 4, 1. Xn plus 2. Xn minus 1, delay it by right. Delay it by 1 towards right. So when you will delay it towards right, so -1 will become 0. So whatever will be at -1, it will become 0. So 0 we have 2. Now 0 will come at 1. So 0 will come at 1. 1 will come at 2. 2 will come at 3. 3 will come at 4. So we have got all this. X of n minus 1. Now x of n by 2, that is the n a is less than 1 expansion. Just what is the scaling factor? A is 1 by 2. So divide the whole axis by 1 by 2. So if I divide it by 1 by 2, what will be their value? -2. So it will start from -2. When you will divide it by 2, you will get 0. So you will get 0. So when you will divide it by 2, it will be 0.5. So the 0.5 we have nothing. So that is 0. Now you will divide it by 2, 1 by 2. It will be 4. So it will come at 4. Like this. So here, when you perform the scaling expansion of any signal in a discrete time, if you will perform any operation, then the expansion, when you perform the expansion, then you have to append the 0 between the two samples. If there are if the scaling factor is suppose 2, then there are 2 minus 1 0 between the two consecutive samples. So two consecutive samples are -1 and 0. So between -1 and 0, we will have one additional sample known as 0. So between the this 2 and the 0, between the 2 and -1, in fact, 2 and minus 1. Between this 2 and minus 1, between this 2 and minus 1, we have 0. Between minus 1 and 3, we have 0. Minus 1 and 3, we have 0. Between 3 and 4, we have 0. Between 3 and 4, we have 0. Between 4 and 1, we have 0. Between 4 and 1, we have 0. Like this is the factor 3. So 3 minus 1 equal to 2. So two zeros we have to append between the two consecutive samples. Like 2 and minus 1, we have two zeros. Here also 0, minus 1 and 3, we have two zeros. So we have to add two samples, two zeros between the two consecutive samples if we are expanding the discrete signal. And if it is 2, if the scaling is greater than 1, that means it is a compression. So when you will compress the signal, then the one sample gone lost, one sample gets lost. So at 0 you are getting minus 1, but now this sample which was present in your original signal, minus 1, after that we had a sample 3. So this 3 will be lost. This 3 will be lost because you are compressing it. So when you compress it, the sample will be lost. So minus 1, then we will directly get 4. After that 4, we have a 0. We don't have a signal. Similarly, from 0, we will have minus 2, but we will not get it because this is next sample. So we miss one sample between the two. If the factor is 2, then we miss one sample. If the factor is 3, then we will miss 3 samples. So we will only get the samples which is in multiple of 2. See, we are getting 0, it is multiple of 2. We are getting the sample which was present at 4. Like this. This is the multiple of 2. This is the multiple of 2, we are getting this sample. If suppose there is a signal present at 4, we will get this sample. Then 5 and 6 we will not get. 5 we will not get. Then 6 we will get. Then 7 we will not get. We will get 8. Okay. So this was the homework question. Okay. This was the homework question that you can draw like for practice. We can like 2, 3, 4, 5, 6, 7. So 2, 3, 4, 5, 6, 7. Okay, like this. Now, suppose I want to draw this one. So whenever this type of signal, there are two type of operation, which is folding and time shifting. When there are two type of operation, then start it from right. So you have to first perform x of n plus 1. X of n plus 1 will, the signal will shift towards left. So the signal was starting from -3. Now it will start from -4. So -4, -3, -2, -1, 0, 1. So it is 2, it is 2, 3, 4, 5, 6. Okay, again started from right, x of minus and -2. So yeah, after that, this is x n plus 1. So now we have drawn as n plus 1, but we wanted to draw minus n plus 1. So minus n means folding. Folding means positive become negative, negative become positive. So it will be get mirror image like this. Seven, 6, 5, 4, 3, and 2. -1, 0, 1, 2, 3, 4. Like this. Okay. So in this way, you have to draw. Always start from right. The signal is missing here, so we are not drawing it. So consider the two signals xt and gt as shown in figure. This is xt and this is gt. We want to represent the gt in terms of xt. So this particular part will be shifting here at 3. It was starting at 0, but now it is starting at 3. So how do you write this particular pulse? X of t minus 3, because it is starting at 3. Now how do you write this pulse? This pulse is nothing but, let us say, we have folded it. So when we folded it, we get x of minus t. And when we inverted it, you will get this thing. And then we have shifted it towards right by 2, because it should start from 1, but it is starting from -1. So x of minus t, so -2. So x of, now if x of t minus 2, so x of t minus 2 will start from here, 2 and 3, and then folding, then it will start at -2, -3. Okay, now tell me, what is this value? What is this value? Is it correct or not? You think and tell me whether it will be correct or not. When you will fold it, it will get minus 3 and it will get minus 2, and then you will invert it, it will be add 3 to 2. What if it is plus? If it is plus 2, then it will be like minus 2 and 1, minus 1. Come on, tell me. Can you tell what should be the this value? Okay, so this is written. Now let's see the types of signals. What are the standard types of signals? So the standard types of signals are unit step, signum, unit impulse, rectangular, triangular, sync, sampling, exponential, sinusoidal, and ramp. These are the standard signals that you will regularly encounter in this signals and system course. So in the unit step signal, the unit step signal is defined as for t greater than equal to 0, it is 1. For t greater than 0, it is 1. For t equal to 0, it is 0.5. For t less than 0, it is 0. So you can see this pulse at t equal to 0, it is a step actually. It is a step. So that is, it is suddenly changing the value. Step signal means it is suddenly changing the value from 0 to 1. And after t greater than 0, it will remain at 1. And when the t is less than 0, it is 0. Unit step sequence. Step sequence means it is a discrete signal. So discrete signal will have the discrete in value of time. It only has the integer values like 0, 1, 2, 3, and minus 1, minus 2, minus 3, and so on. But because this is a unit step signal only exists for positive values of n and for n equal to 0. So for n greater than equal to 0, it is 1. For n less than 0, it is 0. Then the ramp signal, same procedure. For t greater than equal to 0, it has t. The ramp signal rt is equal to t for t greater than equal to 0, and for t less than 0, it is 0. Okay, so if there is a k, that means the slope of the signal is k. If there is a k, that means the slope of the signal is k. T greater than equal to 0, it is t. T less than equal to 0, it is 0. And the ramp signal is generated by t into ut. The ramp signal is generated by t into ut. So if it is written 5 RT, then it is slope is 5. The unit ramp sequence. So for the integer value of time, the slope will be increasing linearly. So for n equal to 0, it is 0 because we write n. For n greater than 0, it is n. So when you put n 0, it will be 0. When you put n 1, it will be 1. You will put 2, it will be 2, 3, 3, 4, 4, and so on.
Hello? 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 Hello?
Yes, at t equal to 0, ut is equal to 1. Ut is 1. Ut is, ut is 0.5, un is 1. Okay, okay. So ut is 0.5 by Gibbs phenomena. This is Gibbs property that positive side and negative side we have 0.5. But mostly we don't use it. Mostly we don't use it, but it could be the representation. But in the discrete case, it is exactly 1. Ut is 0.5 at t equal to 0. That we can write. If suppose not able to write, or if you it is not required, or if you suppose you are not getting answer, then you can take 1. But 0.5 is just the representation. We haven't used it. Like if the RT is the unit ramp, this is unit ramp which is having the slope 1, then R minus t plus 2 we have to draw. So again start from right, RT plus 2. RT plus 2 means starting from this is RT plus 2. Then fold it by minus 1. That means minus 1 means folding. So divide it by minus 1. So this will become plus 2, this will become 0, this will become minus 1. So plus 2 minus 1, plus 2 0 minus 1. Mostly ut at t equal to 0 is 1. Now suppose this is the signal which you want to represent in terms of ramp. So always look for the point which has the slope change. Like this is the point where there is a change in slope. This is the point where the change in slope. The minus one, before the minus one, the slope of the signal was zero because it was flat line. Now after minus one, this is the ramp. So there is a slope. Slope is 1. I hope that you know how to calculate the slope, height upon base, or you can simply apply y2 minus y1 divided by x2 minus x1. That is the slope. Okay, so at minus 1 there is a change in slope. So first of all, write RT plus 1 because it is minus 1. So write RT plus 1. Now what is the change in slope? Final slope minus initial slope. Final slope is 1, initial slope was 0. So 1 minus 0. So you write 1 minus 0 here. Now there is a change in slope at 0. 0 means RT. What is the change in slope? Final slope is 0, initial slope is 1. So 0 minus 1 is minus 1. So that is GT. Okay. So RT plus 1 minus RT. Remember that the change in slope means represented by a ramp. If change in amplitude means represented it by step signal. If there is a change in amplitude, then represented by step signal. Like in this case, slope is 0 before this point 0. Slope here at this point, there is a change in slope and there is a change in amplitude also. Because the slope becomes 0 and amplitude is also changed from 1 to 0. Amplitude here is 1. Now the amplitude after 1 is 0. So there is a change in amplitude. Before 1 the slope was 1 and after 1 the slope is 0. So there is a change in slope also. So at t is equal to 1 we will have unit step and ramp both. So first of all here you have the change in slope. The slope is 1 and final initial slope is 0. So 1 minus 0 is 1. Ramp is RT. Now the final slope minus initial slope. Final slope is 0, initial slope is 1, 0 minus 1 is minus 1, RT minus 1. Now amplitude is also changed. So final amplitude, initial amplitude 0 minus 1 is minus 1 and we will get UT because there is a change in amplitude. And as I told you, whenever there is a change in amplitude, write unit step signal. So minus UT minus 1. Any doubt in this? Any doubt writing this type of expression in terms of ramp or in terms of unit step? Can you represent it by in terms of unit step and ramp?
Hello, am I audible? Hello, hello, sir. Am I audible? Hello, hello. Am I audible, please? Mm,
Change in slope does not mean the change in amplitude always. Like this is the two examples I will tell you. That this slope is starting at 0, and before this the slope is having 0 value, and here the slope is 1. So what is the change in slope? Final minus initial 1 minus 0. Final minus initial 1 minus 0. Where the slope has changed? At 0. And what is the ramp? So this is RT. Okay. Now at this point, there is no change in slope. There is a unit step only. So this is u change in amplitude. At this point, the amplitude is 1. Before this point, the amplitude is just 1. And after this 1, the amplitude is 2. So change in amplitude. Here the amplitude is 2. And here the amplitude was 1. So change in amplitude. So ut minus 1. Change in amplitude is 2 minus 1. Change in amplitude is 2 minus 1. Final minus initial. So ut plus minus 1. Now, here the slope is 0 because this is a flat line, so the slope is 0. And after this point, the slope is minus 2. So, minus 2 RT minus 2. Final slope minus 2. Initial slope 0. Minus 2 minus 0 minus 2. At which point? At 2. So, RT minus 2. So, this is XT. Yes, at every point we have to check whether the slope changes or amplitude changes. According to that, you can write RT or UT. Now try this one. Now just try second one. This is suppose 1, this is 2. Now tell, now tell about this xt. Okay, so check here. There is no, there is slope change. Slope is 5. Here the slope is 0. So 5 RT. At this point, the slope is minus 5. Before that, the slope was 5. So final minus initial minus 10 at t minus 1. Now here also, the slope is 0. Before that, the slope is minus 5. So final minus initial become plus 5. RT minus 2. This will be the answer. It will be plus sign, no? It will be plus sign. See, at point t equal to 0, Aishwarya, see the final slope and the initial slope and the shape of the pulse. If the signal is having the slope, that means the straight line, slanting line, then definitely there is a ramp. You can also identify from the shape now that you already know that which one is unit step and which one is ramp. So here we have a unit step because it is a vertical line, and here we have a ramp. So according to that, you have to decide. Here it is the ramp. So change in slope, final minus initial. So initial slope is 0, final is 5, 5 minus 0. This is 5 minus 0. Now at this point, the slope is changed. Slope was 5, now it is minus 5. Change in slope, minus 5, final slope, initial slope, final minus initial. Final is minus 5, initial is 5. Final minus initial become minus 10. Then after 2, there is no slope. So slope is 0. Final minus initial. 0 minus of minus 5. So this is plus 5. Okay, the last one is positive sign, not negative sign. Okay, so in the next lecture we will cover the types of signal like energy signal, power signal, even odd, periodic or periodic, from where the question is mostly asked. Okay, so that portion we will cover in the next lecture, because today we started late, so it is already 11:15 now. So most of you will might come from the work. So let's start in the next lecture. Okay, next lecture we will continue from here, this point only. We will cover the energy signal, power signal, periodic signal, which is the most important part of signals and system, especially this chapter. Thank you.